So we're going to embark on a series of lessons to do with computer networking. Now on the GCSE Computer Science spec, there's a lot of information, a lot of theory that you need to know about networking. So we're going to break this down into smaller chunks to help you digest it. To begin with, let's consider a device that you will probably have at home. So if you have access to the internet at home, you will have a device like this that's on the screen. It might look slightly differently, but it will perform the same action, okay? It is a Wi-Fi router. Now what's it used for? Well, it allows you to connect to the internet, okay? It's how the internet signal comes into your house. So you'll plug it into your phone line, or if you've got maybe a Virgin broadband, it'll come through a different type of cable, but ultimately a cable will plug from your outside into this router. The Wi-Fi aspect is a misconception. Now a lot of people think Wi-Fi is the internet, when actually that's not true. Wi-Fi is the way we connect to your home network or connect to another network, like in schools, or maybe you're in a Starbucks, wherever it happens to be. It's how we connect to that network, and that network might also have access to the internet. It doesn't necessarily have to be the case that's true. However, 99% of the time that is true. Okay, so the internet will come into your Wi-Fi router, and it will then send off what's known as a wireless access point to allow you to connect wirelessly to the device. Now some of you might also connect devices through cables, through Ethernet cables, and that is no longer using Wi-Fi, but it's still accessing the internet. Okay, so hopefully you can start to see the difference, and we'll explore this topic as it goes on. So there's absolutely tons we need to go through. So today we're going to be focusing on the main types of networks, local area networks and wide area networks, and some basic terminology for networking. So really laying those ground ideas to be able to build up the more complex knowledge. So looking at a network, an image like this, hopefully you're thinking about a social network, a bit like Facebook or things like that, where everybody's connected to other people. You might have a friend of a friend and all that kind of thing. Computer networks are based around the same idea. The word network is really referring to how we all interconnect with one another. A social network, how we interconnect with one another. A computer network is how the computers interconnect. So you can see a very, very similar image, but this time we've got computers connecting together rather than people. So a network is two or more computing devices. Now these do not have to be actual computers. They could be anything which will communicate over a network. So it could be a mobile phone, an iPad, any network device. And the most important thing is that once they have connected to a network, they can communicate in some way. They can send messages, emails, access websites. They can send information from one place to another. And there are two main types of networks that we are going to consider. Okay, the first main type is a local area network. Now this is the type of network you will have at home and also in school. It will cover a small area, okay, small geographical area. Now when we say small, this is relative. Okay, so when we say small, we could mean an entire site like school or even a university. That will be considered a local area network. But these will be obviously different sizes. So your home network will be a local area network, but the size of your house is probably tiny compared to the University of Birmingham, let's say. So they're still local area networks, both of them, but their size is different. A wide area network will cover much wider area. Okay, so we might be talking the entirety of the UK, for example, and this will be a wider area network. And one way to really think about it is a wide area network is made up of a collection of local area networks, and we'll explore that idea later, but think of it in that way, that a wide area network is made up of local area networks, and these might be different branches of a bank, for example, all connecting together to form a wider network. So we're going to look at some images in a moment. I want you to think about whether this is a local area network or a wide area network. Okay, so I'll pause on each one to give you a chance to actually think about it, and then I'll give you the answer. So this is a local area network. In any kind of office environment, whether it's in a single building, no matter how big that building gets, it's still a local area network. As I've already said, a home network is always a local area network because the size of your house, no matter how rich you are, it is going to be a local area network. Now, a corporate network, this one is a little bit more tricky because, again, it depends on whether it's based on one site or is it based on multiple sites. If we're thinking about a place where there's lots of different sites all around the world, all around the country, for example, then it's definitely going to be a wide area network because it's made up of lots of smaller local area networks. So school network will be a local area network again because it's in a small area. So a wide area network can be thought of a collection of local area networks. Okay, so here I've got an image where there's 4 local area networks. Okay, and they are all connected together to form a wide area network. Now, in networking diagrams, we tend to show wide area networks as a cloud because there's normally going to be lots of interconnections to be able to connect it. So the internet, for example, when we connect to the internet is the biggest wide area network in the world, and it's all connected in lots of different ways. And to kind of hide that complexity, to abstract it, we kind of just draw a cloud because it's just too complicated to draw in a diagram. When we connect to a local area network, we'll use a special device called a router. Now, hopefully you're thinking, hang on a second, I've got a router at home. I can connect to the internet. Now, the internet is a wide area network, and I need a router to connect to a wide area network. Ergo, that's why we call it a router. So we're now starting to bring in that kind of base knowledge. So now's a perfect time to pause and make some notes. So make notes on what we mean by the term network. Now, you might think, yeah, I know what network is, don't worry about it. However, it's amazing how easy it is to forget these kind of core ideas when you don't revise them. So making notes on it, even if it's one sentence, which is absolutely fine, it is good practice. Then say what a local area network is and give you 2 examples of it. A wide area network with 2 examples. Now, remember, we've given 2 examples already, a corporation and also the internet. Include a diagram for both of them so you get to see the difference. Now, remember, a wide area network is made up of lots of smaller local area networks all put together, all connected together using routers. That is actually really important because it helps you cement the knowledge of what we mean by the term wide area network. If you got the textbook from UOB School, then pages 21 to 22 will also help you. If not, just Google these terms on the internet, you'll find loads of information. Let's have a bit of an overview of a standard network, say in a school. Now, this is a massively simplified version of a network in a school. However, if we have a too complicated a picture, then it'll be really hard to explain to you guys. So here I've got two rooms, okay? Two ICT rooms inside a school. Now, that's you might have like multiple rooms, 2, 4, 8, whatever. And these are all connected together using a device called a switch, okay? So in a local area network, and when we connect computers together, we'll normally use a switch. And then those switches will connect to a router, which will then give us access to the internet later on. I will kind of bring that part in later. So what are the main considerations we need when communicating between two rooms? Well, the first main consideration we need is, well, how are they actually physically going to be connected? So that connection, there must be a wire being able to connect them together, because otherwise, how on earth would they talk to each other? So in this diagram, you see I've got the computers in one room connected to a switch. There's also a Wi-Fi box, so maybe I've got some iPads in that room as well, and they're connected to the wireless access point. They then connect to a router at the heart of the school. Now, it doesn't necessarily have to be in the center of a school, it just has to be there somewhere. And then we've got the exact same thing mirrored in the other room. So we've got a Wi-Fi box as well as a switch, and they all connect to the router. So if I want to send a message from one computer to another, so let's say I'm going from this PC here over to this PC over here, well, it's going to travel down the cable to the switch. It's then going to go from the switch to the router to the other switch, and then finally the switch to the final PC. So it's a path, okay? We'll call it a route. So in order to send data between two devices, we also need to know what the address of that computer is. Now, if I was sending a letter, I know it's an archaic thing nowadays, but let's say I was sending a letter from myself to someone else in the country, I would need to write down their home address along with their postcode. That information is what the post office will use to be able to find the way for my letter to get from me, when I put it in the letterbox, to the house that I want it to go to. So without an address, there's no way we can get a packet from one place to another. When I say packet, I mean the data and the message I want to send. So in order to uniquely identify a computer, we'll use something called an IP address. Now, an IP address is made up of 4 numbers. Okay, each number is 8 bits long. Okay, so it's made up of 4 numbers, and each number is 8 bits. Now, coming back to your binary, if I wrote 8 ones down, so 1 1 1 1 1 1 1 1, 8 ones, what number would that be in binary if I turned it into denary? So the biggest number we can store in 8 bits is 255. Okay, so an IP address is made up of 4 numbers. Each number is going to be between 0 and 255. Okay, so this is the reason why we have the number range. So it's 4 bytes, each byte having a number between 0 and 255. So every single computer in the network will have this number assigned to them. Okay, this will be assigned maybe by the admin. Okay, so manually assigning it. This is known as a static IP address. Or it could be done automatically by the server using something called a DHCP server, which will automatically pick an IP address that's free and then assign it to that computer. Now at home, in your home network, your router will have a DHCP server built into it, so it will automatically assign IP addresses out to all of your devices that connect to it. In a school network, this also happens. However, it is very common for computers and servers and routers and all those kind of things to be given static IP addresses, so they know exactly which computer has what. So it's easier to maintain and manage them. So let's trace the path of a packet. So the message that contains the destination and sender's IP. So why do you think that's the case? Why would we need the IP address of where we're going to? Hopefully that was fairly obvious, but also where it's come from. And also, why does it have to go directly to the switch? Why does it go via the switch? Why can't it just go straight there? So obviously it will go to the switch first. It will then go to the PC it wants to. Now, in this case, we're going in the same room. So why can't I send it straight to the computer in that room? Why do I have to go to the switch first? Now, the reason for that is, well, there's no connection between that PC and the other PC. There's no actual wire between them. The wire goes to the switch, and then another wire goes from the switch to the other PC. So that's why it has to go via switch first. And why does it need the sender's IP address, i.e. why does the address of the person who sent it need to be included? Well, what happens if I want to send a message back? So that's the reason why. So we always send the IP address of the computer that's sending the information, as well as the destination it's going to. That way we know where to send it to, but also who to send the message back to. So when a message is sent over the network, we call that message a packet. Now, larger messages, so if I have a really long video file, for example, we might have to split that up into small little chunks, and each of those chunks will be sent as a packet. So a packet will be made up of the data I want to send, obviously. It'll also be have the IP address of the sender and the recipient. I've already said why that's the case. And also have other data such as the order it should arrive in. So for whatever reason, maybe the packets arrive out of order, I can put it back into the right order again, because we don't particularly want the ending of a film being shown before the beginning, because that would make no sense. So we order it. We might have error detection information, so if there's something wrong with the packet, and we need to be able to identify that and get the packet resent, etc, etc. So all that information will be kind of put together inside the packet so we can send it over the network, and it will then arrive the way it should do. So splitting packets is actually really important, because it's very common for us to want to send very large files. And we must split it up, because if we didn't, what will happen is we'd have to send the entire maybe 2 GB file over the network. But what happens if that packet goes wrong, if something gets corrupted in it? Over a 2 GB file, it's a very likely thing to happen. And if that's the case, I can't use that file anymore because it's corrupted, so I have to send it again. Now, resending 2 GB file over and over again will be very wasteful, and ergo a really bad idea. So we split packets up into parts. So packets need to be split up, especially if the file is really big. You can think of a packet a bit like an envelope. So if I was going to send a letter to someone, I'd get my envelope, I'll put the letter inside the envelope, I write on the front the person it's going to, and maybe on the back I'll say return to the person who sent it my address. So let's say I'm streaming a movie from Netflix, and that movie has to be broken up into chunks, into smaller parts. We'll include in the packets the IP address of where the video is going to. So in this case, the video is going from Netflix all the way to this PC over here. So we're going to include the destination IP address here. But also, we'll include the source IP address, just in case we want to send another message across, saying please can I have this packet again because maybe it got corrupted, or can I have the next part of the movie or the next episode, whatever it happens to be. It needs to be able to send messages back, basically. So the first part of the movie will be packaged up into the envelope or the packet, and the information that it needs will be placed inside that packet as well. So the source IP address and the destination. That will be then sent across the internet to the computer that it's going to, and that will then read that packet through. The next packet will be then sent in the exact same way, so we'll package it up into a packet, add on the source and IP address, the 2 IP addresses, and again send it, and the same thing over and over again. So the next thing to do is add on what we mean by the term IP address, this unique number that's assigned to computers on the internet. You need to make sure that you explain why we need the IP address. Why does it have to be unique? Okay, that is really important. How is it structured? This ID is made up of 4 separate numbers, and each number between 0 and 255. And also, why does the packet need to contain both the sender and destination IP addresses? Why do we have this extra information inside the packet when we send each one? It's also really a good idea to explain why we split packets up, the messages up into smaller chunks before sending it over the internet. If you want a little bit of a challenge, maybe do a bit of research on what is known as a DHCP server. There's lots of information about it on the internet, but it will be interesting to actually research that. Also, it's probably worthwhile explain what's meant by the term packet, and you can refer back to this video if you need to. So, the next thing we're going to look at is MAC addresses. Now, a MAC address is different to an IP address. So, MAC addresses are hardware MAC addresses. These are not assigned by the network administrator. They're actually put onto the device themselves by the manufacturer. You cannot change MAC addresses, or you can't change them easily anyway. They are made up of 12 hexadecimal digits. Okay, so where an IP address is made up of 4 numbers, MAC addresses are made up of 12 hex. So if you figure out how many bytes that is, remember each hex digit is 4 bits. So if I have 12 of them, that's going to be 6 bytes. So it's slightly big. So before we go into detail why you got 2 different types, just explain what we mean by the term MAC address, because these are probably very alien to most of you. Okay, so what is a MAC address? It's a hardware address which is assigned directly to the hardware device. How to construct it is made up of 12 hexadecimal digits. It's assigned by the manufacturer, and obviously give some examples. So now's the time to actually start to bring together all this knowledge we've just looked at and go back to our kind of big question. What's the difference between a network and the internet? Because a lot of people, when they think about networking, they just think about the internet. They just think about the web, if I'm honest. They don't really think about the internet. A computer network is where 2 or more computer devices are linked together so they communicate. That's what we mean by network. This does not mean websites yet. Okay, we haven't even got anywhere near there, because we could technically connect 2 computers together and play a computer game, and that's it. We don't have to use the internet. Networks like your home and school will be a local area network, and larger corporations or the internet will be known as a wide area network. So there are many local area networks across the world. Okay, lots of them. Your home will be one, the school is one, the university is another one, every company is another one. So there's lots of all networks. All these networks need to communicate with one another. So for example, at home, I will want to be able to send and communicate over the internet, so I can look at web pages, look at YouTube, etc, etc. So we need to be able to connect to the internet. So all of these local area networks that have access to the internet actually are forming the internet. Okay, the internet is actually an interconnected collection of local area networks. That is what it is. So we have all these local area networks across the world. Put a few in there, but you get the idea. Each one of these are connected to a router, and that router is then connected to other routers, and they form a kind of a spider web of routers, all interconnected, to allow us to send data to and from different local area networks. So a router's job is to send data to the correct destination. So it has this kind of job of being able to route packets between local area networks. Okay, rather than between computers on a network, it's between local area networks around a wide area network. So the term internet stands for an interconnected collection of networks. Net being short for networks, inter talking about this interconnection of local area networks. So it's really important to understand this idea. It's a collection of networks, local area networks to be precise, rather than it's the web, okay, because they're not the same thing. So it's a good idea to make some notes on this now, and this is where this video will end. I'm sure you're glad about that. There's a lot of information here. I'm sorry about that. It is what it is. The internet is an example of a wide area network. Explain what the term internet means. Be really clear about this idea that it's an interconnected collection of local area networks, because it helps you understand what we mean by the term internet, because a lot of people do not understand that. Explain what the term internet means, explain why it is a wide area network as well. So why do we refer to the internet as a wide area network? And remember, we call the wide area network a collection of local area networks connected together with a router. What is the internet? Well, there's lots of wide local area networks connected together using routers. That's why it's all WAN. So why do you think LAN networks are considered more secure than WAN networks? That's kind of a bit of a challenge for you to research. That actually becomes a big thing later on when we start talking about encryption and security and threats and things like that. So it's well worth having a little bit of a think about it now to kind of prime yourself ready for the next bit of knowledge. Thank you very much, and I'm sorry there was so much information in this video. There's a lot of information in networking, I'm afraid. I hopefully have explained that as much detail as I can do. If you do have questions, please do let me know. You can email me in the normal way, and I'll do my best to explain it to you. Thank you very much.